Hey, and welcome back to the lab. And today here on the bench we have a YAESU FTDX-10. And the FTDX-10 came in because the operator told me that there is no output power. So absolutely nothing. And as you can see here, it is running, and we will see that the radio receives, but let's check if there is really no output power, and then let's see what we can do. Alright, and as you can see, the radio is already connected to our radio tester, and well, obviously it is receiving, so let's hear. And yes, you see it is receiving strong and clear, so no matter what, we have no problem with receive. So let's test how it looks like when we test it on transmit. Okay, so now I have set it here to my LP500, and microphone is on. We're still on USB, and so there is absolutely nothing. So let me check. Yeah, okay, mic gain is on 30. So let me bring it up to, let's say, 50. Once again, no, nothing. Okay, so our RF power is set to 35 watt. Okay, and now let me crank it up to 100 watt, which is the maximum. Let's check it again. I mean, you see it is switching, and when I'm talking, so you can see that it is producing audio, but we do not see no power on our LP500, and we do not see here our power output here on our meter, so it should also indicate in this case 100 watt, but it is not. So is there another setting what I have not considered yet? But no, I don't think so. I mean, what we can do, for instance, we can set, if we like, the radio to FM, because now we do not need audio. So therefore, when I press, we should see power output, but as you can see, it is totally dead, so no output power at all. So let's look what's going on here. Having a problem like this always means, where can we start? And therefore, let's have a look into our service manual to see where we really can go. Alright, and since this is an SDR radio, you can see that we have here in the middle our SDR module, so that is mentioned up here, and finally that is an FPGA which is producing our transmitting signal directly. So it really comes out directly here, TX1, and it is going directly up to our power amplifier, so to our final unit. Alright, and there it gets in, and then we can follow along. So, you know, alright, we could test here at the output of our FPGA, but it is much easier because it is easier to get to the testing points onto our final PCB, and we check if the signal it's getting until to, let me see, where it is. So hang on a second. So we have here, all right, so we have here our first amplifier. So you see our signal is directly coming up from our SDR stage, getting in, and we have here our first amplifier. And well, the easiest is to check, is our signal here, and do we get our needed 5 volt here for our amplifier. So that will be the first we do. Alright, and as you easily can see, here is our amplifier PCB. So our power amplifier is here down beneath this coil, and we have here driver stage and so forth and so forth. And as far as I've seen it on the PCB plan, our little preamplifier, let it call it that way, is under our loudspeaker. So the first what we need to do is we have to take out here our speaker. Okay, unfortunately my camera didn't record. I don't know why, so I lost one or two, I guess two clips. Anyhow, I explain you what has happened in between. So let's look here onto the PCB. So you see the speaker is gone, and when we go down here, we find here, down here, we find a little amplifier. So that is the amplifier what we have already discussed. And we see here, right beneath, a little coil which is feeding our amplifier with voltage. And that is 5 volt we have seen in the block diagram, right? So I've already taken out this little coil here. Okay, so now you might ask why. Very easy. So as we have seen, this little amplifier gets supplied by or with 5 volt, which is generated up here. So we have here 2 voltage regulators. One is 5 volt and the other one is 8 volt, right? So, and of course I have tested the both regulators, and I found that our 5 volt regulator is not at 5 volt but at around 3.5 volt, something like that. So that means that is wrong, and I thought, okay, do we have a wrong voltage regulator, or do we have something wrong here with our amplifier? And so let me show you how it looks like in the schematic, then you understand what I've done. Okay, so look here. So we have here this little amplifier. So you see the signal is coming here into our final unit, so that is coming from our main unit over here into our little amplifier chip. And what you see is that it gets fed with voltage on pin 3, which is at the same time our output. You see it here, and we have here the little coil in the feeding path for our supply, right? And when we go over and follow along the line, so here, here, down here, and then we go over, and you see we get here our 5 volt supply. Okay, and the next step is we need to go down here on our diagram, and here you see that our 5-volt regulator gets fed by 13.8 volts, so that is literally our supply voltage out of our power supply, if you like, and that is then going to, no, that is the 8 volt. We have the 5 volt, and that is going here to our little amplifier. Right, so that power regulator, or that voltage regulator, was pulled down, and I have taken the little coil out, and now we have back our 5 volt. Okay, so let us check what we have down here. So here we have our both voltage regulators. So the first one here, that is a 5 volt regulator, and here is our input, 13.3 volt, which is fine. And on the other side we have our output, which is, as you can see, 5.05. So yeah, the second one is also input 13.5, and then on the other side we have our 8 volt. And of course this 5 volt, what we have seen there, should be down at, you know, where our little coil was in the circuit, and you see there we have our 5 volt. So it looks everything fine. I mean, our 5 volt regulator was really under stress. I don't know how long, but it definitely was under stress, and we do not really know if maybe that it produces a problem when everything is back, that it then maybe collapses. We will see, but for the moment it looks fine. So therefore let's simply go ahead and let's have a closer look to our little amplifier, right? Alright, if our little transistor here, this one, is really pulling down the voltage in a way that a 5 volt regulator can't deliver the ampage, then it must have a kind of short, and that should be something we should be able to test. I mean, simply with an ohm meter. So let me take the camera in the right position, and then we check it. Okay, so this way you should be able to follow. It is set to ohm. Okay, so when I now put the both leads together, it's not very good here, so let me go here that we can see it better. So you see it is 0.0 ohm, and now when I go one side to ground and the other side to our coil connector, which is delivering our supply voltage, so let's see what we get, and it is, as you can see, 0.5 of an ohm. Okay, and that is clearly indicating that our little chip here inside is toasted. So that means we need to take it off, and then we go ahead. And this task we can easily handle by hot air, so we just take it out using the hot air reflow station, and then we can go ahead. Alright, so our component is out, and that was a little bit tricky. So a lot of ground plane to overcome, so really hard stuff. Anyways, so we have here now our little component connected to our tester, and let's test. Let's test what we got. Yeah, and that is exactly what we have seen before. So look here, there is no resistance in between, so that is a short, and the other side of our little transistor showing 37.7 ohm, which is also a resistor, but no transistor any longer. So yes, it is definitely toasted, and therefore let's put in a new one. Okay, so everything is clean here in our area, and that means we are able to place a new transistor. And over here we have already our spare part, so that is our needed transistor, and that is our needed coil. So that is what we now put in. Okay, so our new amplifier is in. So if we go down to our area of interest, so you see we have of course our new little amplifier in and our new coil. If you wonder why I put a new coil in, so that is quite simple. So if we have a toasted transistor in this case, which is nearly shorted, so that means that a lot of current was flowing over our little coil, and that means that we cannot be sure if it is internally shorted or the insulation of the wire is broken, so that it shorts now, and that means it does not really is a coil any longer. It might be a wire or such, but not a coil. But this coil is extremely important, because you have seen that we feed our little transistor on the output side with our DC, okay? And on the other hand, we get here our HF in, which gets amplified. So, at this point we have both our DC voltage and, of course, our HF or RF, whatever you want to call it. But we need this coil in order that, the RF or HF can't go back into our DC pass. So if this here is not 100% fine, then we really get a mismatch of everything. So therefore, you always should swap your coil together with a fold component. That's the reason why we did it. Okay, and now let's check if it works. First of all, let's switch on. Yeah, and yes, that is obviously working. So we have tone over our external speaker, because the internal is still here disconnected from our radio. Okay, so let me see. Our RF power is set to 100 watt, but let us go lower for the first test. So let's say we put it to 10. Let me take this down. We put it to 10, and now let me reposition the camera. Okay, so I believe we can see both. Okay. Right, so what was the dialed in power? Okay, 10 watt. So let's see what happens. So it is set to upper sideband. No, let me put it to FM, so we do not need a tone. And let's see what happens. Wow, it's okay, and we see we have our audio as well on FM, but we can clearly see 1 2 1 2. So our needle here is pointing to 10. Not sure if you can see it. Our power output meter here is pointing to 10. Very nice. And in reality it is 13 watt. So well, all the FTDX-10 are putting out a little bit more power than you know, indicated. So let's go up to 100 watt, and normally this radio is putting out between 115 and 120, something like that. So let's see what it is in reality. We are still on FM. Let's see what it is outputting. 121 watt, perfect. And yes, here on the meter as well. Now let me put it to upper sideband SSB, and let's see if it is working on audio. So let's go over to our meter. One, two, audio. And you see it's putting out 130 watt, which is normal for this radio. So as I said, they always putting a little bit more out. 1, 2, audio. So that is pretty nice. So let me go and let's check here our PO, power output. 1, 2, audio. 1, 2. Let me put it back to FM. Come on. Okay, and now let me see. Yes, it's exactly pointing 100 watt. So that is how the FTDX-10 are adjusted from factory. So that is great. This is fantastic. Okay, so you see, radio is fixed, and well, sometimes it is only a little transistor which you know, makes everything a little bit dramatic, but now it's fine. And yes. All right, and what I wanted to check out, of course, is if our receiver is working as well. And as you can hear, yes, it is working perfect. It's really working perfect. Let me turn it down. I just wanted to see if yes, receiver is working, and it is, and that means finally radio is back working, and that means as well we are at the end of our video. Hope you learned something, and catch you next time. Bye.